This is the third video for Chapter 12. Agenda. In this short video, I'll discuss the following three topics. Topic number 1, how to name a cell or cells. This is for the benefit of the next two topics. Topic number 2, how to conduct multinomial distribution goodness of fit test. Topic number 3, testing equality of population proportions for 3 or more populations.
Shutterstock Music.
Topic number 1, name one cell or group of cells. Okay, and just simply click .ice. Okay, so this is name a cell or cells, and topic 52. Okay, this up arrow key, we enter 52. Choose 2 cell, then enter RF 0.05, then choose 0.05, and then we can use our formula. Okay, the second method is we click formula on the menu bar, define name, cal. I'm going to do it, show you how to do it. Okay, suppose we randomly pick up a cell and we enter 1%. Okay, suppose we have a formula, it's 1 plus risk-free rate. Okay, suppose our formula is 1 plus risk-free rate. Okay. Conventionally, we use 1 plus, and so this is C3, so we enter this one. So 1% plus 1 is 1.01. So this is show formula. Okay, we are going to show the formula. Okay, the formula is 1 plus 3. Okay, it's also true we define other variables. Okay, so the easy way to define is we call this cell with 3. Then it's not 1 plus C3, it's 1 plus with 3. Okay, how can we do it? We move the cursor here. We click formulas on the menu bar. Okay, we click define names. Okay, so with 3, this is name and refers to location of $C and $3. Just click OK. Okay, so this is 1. Suppose we have 1 plus with 3. Okay, now it's 1 plus. So instead of C3, we type RF. Okay, RF, then enter. So this is our formula. So this is our formula. So this is 1 plus with 3. And suppose this is 5%. So this is 1.05, 1.05. Okay, the advantage of this way, there are 2 advantages. The first one is we don't have to go to our spreadsheet looking for specific cells. We only to type correct name. The second advantage is it's corresponding to our formula. Okay, I'll give you another example. Suppose we have some values. Okay, we have some values. Okay, we have a set of values. Okay, so let's calculate average. So this is we calculate average. Okay, highlight and so let's look at the formula. Okay. So this is our formula. Okay, so our formula is from H4 to H17. So usually we do this way. Okay, another way to do it is we name it. Okay, we name it called my data. You can use your own name. Okay, formula, define name. So let's call it my data. Okay, so this is my data. So if we calculate average, so I use my data. Okay, my data. Okay, I'm going to show the formula. Okay, so this is my data. Okay, alternatively, you see standard deviation. Okay, we can also use my data. Okay, and so conventional we use H4 to H17. However, if we define this one as my data, then instead of H4 to H17, we use average, my data, standard deviation, my data. So this is end of topic number 1. Topic number 2, let's conduct a test. Okay, .ice. And so this is 53. So loyalty for the automobile. Okay, so this is enter 53. Okay. We begin by taking a sample of owner from each of the 3 populations. So each sample contains categorical data, yes or no, whether the respondent are likely or not likely to repurchase the automobile. Okay, and so step 1, we get the data. Step 2, we generate a table. Okay, I'm going to show the 2 tables. One is, so we have 2 by 3, 2 rows, 3 columns. Okay, 3 different brands, and yes or no. Okay, and step 3, we generate second table, expected. Then we apply this formula to calculate the A minus B squared divided by B. So this summation will be chi-square. Then we compare with the critical chi-square. So step 5 is related to topic number 3. Okay. So this is how to get the data. Okay, so method 1, and use dot A, we enter the keywords. We got ID 184. Okay, dot B 184. Then we go back to our Excel. And method 2, method 3 is, so you can just copy this line and copy paste to a browser, then download CSV file. Alternatively, you can copy this line to download a text file or copy a text file. Okay, so let's use dot B 184. Okay, 184. And so this is the name of data set. So we go back to Excel. Okay. And I post these 2 tables here already. Okay, so let's choose A1 and we paste our data here. Okay, so we have 2 columns. Okay, the first column is automobile. Actually, you'll see that 1, 2, 3. The 3 type. Just going down. Then, so this is type 2, yes or no, and going back. Okay, and so we are going to generate table 1 first. Okay, and so let's highlight both columns. Control Shift down arrow. Okay, click Insert. Click Pivotal Table on the top left, and you can choose. Click Insert Pivot Table, enter the region here, okay, because I select already. Okay, then click OK. This is our new spreadsheet. Okay, and we have automobile first column, the second column, and yes or no. Okay, and we grab it, put it here. So this is yes or no. Okay, and then we grab it. we grab this one ultimately to the column. Okay. Sorry, cannot see it completely. And so this is row and this is column. Okay. Okay, I repeat. Okay, I'm going to uncheck that. Okay. And first one is I grab here. So this is row, yes or no, yes or no. And also for the ultimate view, I choose 2 columns. Okay. So this is 2 by 3, 3 by 3, 2 by 3 matrix, and the value is count of yes or no. So we grab this one. Okay. And so this is no, and 1, 2, 3, this is total, and yes, 1, 2, 3, this is total. Okay. I'm going to copy, paste, and I'll go back to my here. Okay, just choose any location. I paste as value, so this is 1, 2, 3. I make it a little bit bigger. Okay, this is almost identical to this one. Again, so this is our observed. This is our survey result. Okay, this is survey result. Just like compare. So yes, 69, 120, 69, 120, 123, 3, 2, 1. Okay, final total is 500. Okay, no ahead of yes because this is sorting. It's sorted. Okay. Okay, so let's generate the second table. Okay, I'm going to copy paste. I'm going to copy paste this part. Okay, I'm going to, so actually I don't need okay, I'm going to copy paste this part. I'm going to copy as little as possible. Okay. Okay, I'm going to generate this 1, 2, 3, 6 numbers. Okay, to generate these 6 numbers, so let's look at we have 500, right? We have 500. So let's look at proportion of each brand. Okay, so this is 125 over total 500. So if we have 500 people surveyed, okay, 25 from Chevy, and so let's use $ signs to fix the range. Then we just copy and paste. Okay, 500, 25% for the first type car, and 60% for second type, and 35% for the second. For the last is for the Honda, third brand. Okay. Okay. Because we know this is 188, right? So this is 188 is no. Okay. So 188 should be 25% of 188 should be Chevy. Okay, so first number should be, so this is percentage. Percentage times total. Okay, so this is 47 here. Okay. Again, I'll explain the logic, okay? The number of people said no is 188. And we know there are 25% purchase Chevy, 40% purchase Ford, and 35% purchase Honda, okay? So this 188 should distribute according to 25, 40, and 35, okay? Then we call this expected. Expected. Okay, so this is related to table number 2. Okay. Before we copy and paste, we have to see. So if we copy down, okay, so this one should be fixed. So E7. Because we have to copy horizontally, so we have the fixed 7. Okay, we don't fix the E. Okay, we don't fix the E. Okay, okay, when we copy horizontally, and so this one should fix. H is 188. Okay, so this is H column should be fixed. Okay, so we fix H column. Okay, you see when we copy horizontally. Okay, so the first one 47, 75.2, 75.2, 65.8, 65.8. Okay, then we copy horizontally and vertically, and we click there. Okay, so let's look at the yes. Yes is 78, 124.8, 109.2. Okay. Okay. Now we have two tables. Okay, so we have 6 numbers. Can make them purple. Okay, let's make them red again. Okay, so we compare this 6 number with these 6 numbers. Okay, then we are going to apply the formula. Okay, the formula will be, I'm going to choose one value. Okay, so A minus B squared divided by, so this is formula. Okay, A minus B squared divided by B. So this is our formula. Okay, so let's copy this table. Okay, so let's copy this table and here. Okay, so let's copy this table here. So let's remove these 6 numbers. Okay, okay. So our formula will be A minus B squared divided by B. So this is A realized minus expected. The power is 2 divided by expected. Okay, so this is A minus B squared divided by B. So let's copy and paste. Okay, so this is our chi-square. So this is our chi-square value. It's simply the summation. Okay, it's simply a summation. So sum of these 6 values will be our summation. Okay, and our n equals 2. N equals 2. N equals 3, because this is 2 by 3, so 2 rows, 3 columns. Okay, so degree of freedom is simply equals n minus 1 times n minus 1. So actually it's 2. Okay, so let's show formula. It's simply 3 minus 1 actually 2 times 2 minus 1 2 times 1, so it equals 2. Okay, so assume our alpha is 5%, so this is 5%. Okay, our critical value chisq, so our critical value equals chisq inverse right hand. Okay, the probability is 5% and degree of freedom is simply 2. So this is 5. I'm going to show the formula. And so this is our decision rule. Okay, the first one is distance. Okay, the distance rule. So if our value, our chi-square value, is higher than critical value, then we reject. Otherwise, we accept. Okay, obviously, we reject because 7.89 is higher than 5.99. Okay, 5.99. It suggests it's different. it's not homogeneously distributed. Okay, so let's calculate p-value. So let's calculate p-value. So p-value will be chisq distribution right hand side. Okay, we enter our chi-square value, then we enter our degree of freedom. So it's 2. So this is our p-value. Okay, it's a p-value. Okay. Again, the criteria is p versus alpha. So if our p-value is less than alpha, and we reject. Otherwise, we accept. Obviously, we have the same result. Reject and also reject. Okay, so let me summarize this exercise. Okay, and first step, we download the data. Okay, we have 2 columns. One, we have 3 types of cars, and second one is yes or no. Good, we are going to purchase this car again. No is we don't want to purchase the same car next time. So yes or no. Okay, our objective is test whether this yes no the same across different categories. Okay, and the first one, we are going to generate 3 2x3 tables. We highlight our data. We click insert pivot table. We generate this 2x3 matrix. So this is our observed. Then we calculate expected. So what is expect value to say no? Because there are 188 people say no, and 25 of them should belong to first category, and 40% of 188 belong to the second category. Continue this way. So we generate a second table. Okay, so this is 2x3 from the observed data. So this is 2x3 for expected data. Okay, then we calculate according to this formula. We calculate another 2x3 matrix. So A minus B squared power divided by B. So this is our first value. Okay, the summation will be our chi-square value. Okay, so summation will be our chi-square value. Okay, I'm going to use. The summation will be our chi-square value. Okay, so this is its total summation. Okay, then we calculate the critical value. Alpha is 2%. Sorry, alpha is 5%. Degree of freedom is 2. Then we apply chisq dot inverse dot rt. RT stands for right tail. So this is 5%. This is 2. So this is critical value. So then we apply the first decision rule. If our calculate chi-square is higher than chi-critical, we reject, otherwise we accept. Alternatively, we calculate p-value. So we apply chisq dot dist dot right tail rt. So this is our chi-square value. So this is degree of freedom. Again, if a p-value is less than alpha, we reject. Because the p-value is 1.9%, is less than 5%, we reject. From topic number 2, we know observed and expected are different. So our conclusion is they are different. Okay. Now, let's look at 2 cars, 2 brands, okay, to see whether they equal or not. Okay. And so let's go back to our pivotal table. So let's get our this value. Okay. So let's highlight. We copy and we paste as value. Okay, we paste as value. I'm going to make a little bigger. Okay. So let's look at the P1. So P1 is 65 years over total. So this is, so actually this is P1 and P2 and P3. So the P1 is proportion of surveyed people say yes, they are going to purchase. Okay, so this is yes divided by total. Okay, okay, I'm going to copy paste. Okay, so P1 proportion the people purchase Chevy. 55% say yes, we are going to buy again, and 60 for the Ford say yes, and 70% say yes, we are going to purchase. Okay, our question is, are these two values same thing? Are these two values same thing, or 55%, 70% are same? Okay, so actually this is our questions. Okay, and so we are going to use P1, P2, and P3, and N1, N2, and N3. Make our calculation easy. Okay, so this is P1. We can just manually type P2 and P3. So proportion for the first car, 55%, 60%, and 70%. So this is N1 total. Okay. I'm going to explain why I do this way. So this is N1, so this is N2, and this is N3. Okay, and because I'm going to, so this is, so basic idea is, for example, we compare Chevy and Ford. Okay, so 52%, suppose we compare these two numbers. Okay, so absolute values are different between these two values compared with critical value. Okay, so it's difficult to calculate this critical value. Okay, to make it easy, so I call this one A, the square root we call B, the C. Okay, and we're going to test 1. Okay, so this is so let's call it absolute P1 minus P2. Okay, so this is absolute. Okay, so let's define this as P1. So this is, we click this cell, we click formula, define, you see P1 underscore. So this is C12, click OK. Then we do the exact same thing, formula, define, so P2 underscore C13. Okay, formula, define, so this P3 underscore, and so click formula, define, so the N1 underscore. Okay, so this is formula, define, so N2 underscore. Finally, formula, define, N3 underscore. Okay, and so let's look at the pair. I'm going to make it. Okay, part 1 versus part 2. So we have the first pair. Okay, so absolute value will be absolute. Okay, P1 underscore minus P2 underscore. So absolute ABS. Okay, so this is 48.048, same as here. Okay, I'm going to use show formula. So show the formula. You see, the beauty of this method is the same thing. You see, the absolute P1 minus P2. The absolute P1 minus P2. Okay, and we can also calculate this one. Okay, so let's only look at the first pair. Okay, then we want to calculate critical value, right? Critical value, 1 versus 2. Okay, so let's calculate A, B, C. Okay, and Okay, so let's alpha equals 2. Okay, degree of freedom will be equal 3 minus 1. Okay, so degree of freedom is 2. Okay, so make it simple 2. Okay, so critical value. The critical value will be chisq dot inverse right hand. So this is alpha should be 5%. Okay, so this is ch. So this is 5%, and degree of freedom is 2. So we know it's 5.99. Okay. Show the formula. Okay. Okay, so what is A value? So let's A value. So this is A. Okay, actually C equals A times square root B plus C. Okay, make it easy. Okay, so this is our critical value. Okay, so A is square root of critical value. So this is A. So this is B. This is C. Okay, square root of B plus C. Okay, so this is A. A will be square root of our critical value. So critical value is 5.99. So this is our A. Okay, square root of chi-square critical value. Our B value will be, you see here, the P1 underscore times 1 minus P1 underscore divided by N1 underscore. Okay, I'm going to show the formula. I'm going to copy this one to here. Okay, so A is simply square root of critical value, 5.99. Okay, B, and according to this definition, is P1 times 1 minus P1 divided by N1. Okay, now this one, same thing, P2 times 1 minus P2 underscore divided by N2 underscore. Okay, so this is, I'm going to copy. Okay, so the square root is B plus C. Okay, the B is P1 underscore times 1 minus P1 underscore divided by N1, P2 times 1 minus P2 divided by N2. Okay, finally, our value. So this is equal A times square root B plus C. Okay, B plus C. Then we got 1.38. So this is so this is our 1.38. Okay, and now this is our decision. Okay, our decision rule is we compare our value, the absolute difference, and absolute difference compare with the critical value. Okay, if this value is less than this value, then they are same. Otherwise, they are different. Okay, so if our value is less than critical value, then you can type same. Otherwise, different. Okay, same or different. Okay, I repeat our objective. Okay, so our objective is we want to compare two types of car, Chevy and Ford. Okay, and suppose we calculate P1 and P2. Okay, P1 is proportion of people they purchase Chevy. They are going to purchase Chevy again. okay, is 55%. And 60% claim they are going to purchase Ford again. So our question is, are they equal? 55% and 60%. Our conclusion is yes, they are equal. There's no difference. How can we do it? Okay, and we calculate absolute difference. Okay, so this is our absolute difference. So actually is 0.6 minus 0.552. The absolute difference is 4.8%. So 4.8%. Then we, according to this formula, we calculate critical value. To make our calculation easier, so we defined A as square root of critical value, B as P1 times 1 minus P1 divided by N1, C as P2 times 1 plus 1 minus P2 divided by N2. So critical value is A times square root of 2. Okay, so this is, I'm going to copy this critical value. Okay, so this is our critical value. Okay, so our critical value is A times square root B plus C. Of course, you can define this value as A, this value as B, this value as C, and make our calculation of formula easy to understand. Okay, I stop here for this exercise. Okay, I only calculate first pair, and as exercise or challenging task, you can compare these two values and also compare P1 and P3.
Shutterstock Music.